So we're going to use something called the work kinetic energy theorem. If you want to reference the book for this, this is found in section 5.2. So in order to derive the work kinetic energy theorem, we are going to start out with Newton's second law as well as the third kinematic equation. So Newton's second law tells us that F net equals ma, and our third kinematic equation is Vf squared equals Vo squared plus 2a delta d. Okay, now we just learned that the net work is equal to the force times distance. So the net force times the distance. And according to Newton's second law, F net is equal to ma. So let's go ahead and substitute that in for F net. We get ma times delta d, which is equal to net work. And let's use our third kinematic equation to solve for a delta d. So if we solve for a delta d here, we can plug in a delta d right here. So when we solve for a delta d, we get Vf squared, subtract that V initial squared on both sides, you get Vf squared minus Vo squared, and divide by 2 gives us a delta d. Let's substitute that in right here. We get net work equals m times Vf squared minus Vo squared over 2. And this may look familiar to you. You may notice that, well, let's pull out that 2, so we get a 1/2, and we have an m here, 1/2 m, multiplied by both the V final squared, subtract 1/2 m V initial squared. That should look familiar to you. That is our kinetic energy equation. So we can say that the net work on an object is equal to kinetic energy final minus kinetic energy initial. And we all know that a final minus an initial is just the change in something. So our net work is equal to delta KE. This is the actual equation that you are given on your AP formula sheet. However, you will need to know how to manipulate this using this equation primarily. So let's do an example using this. Example number 1. How much work is done on a 40 kilogram scooter to bring it to a speed of 20 meters per second from rest? So first thing we need to do is write down our givens. So our givens are, its velocity initial is 20 meters per second and its velocity final is 0 meters per second. We want to know work, and we know its mass. So on an AP exam, you should be able to write down the givens and figure out, where can I go from here? What equation could I use from my equation bank to help me solve this? So that's where you can pick that equation that we just derived. The net work is equal to the change in kinetic energy, and you end up getting 1/2 mv final squared minus 1/2 mv initial squared. Go ahead and plug in our givens. You'll notice that the second term does drop out because it has a velocity of 0, which makes this whole entire factor become 0. And you get a net work of 8,000 joules. And since our givens, our smallest given has 2 significant figures, we would want to write 8 times 10 to the 3rd joules as our final answer. Okay, one more example. a 0.2 kilogram baseball traveling at 30 meters per second moves from a catcher's glove back 10 centimeters as it is brought to rest. What is the average force on the ball? So this one's a little bit different. We're actually incorporating force. So let's go ahead and write our givens. Actually, this one we might want to go ahead and draw a picture to help us out first. So we have our glove here. We have the ball just hit the glove, and it's moving. The ball's moving this way. So its displacement's going to be to the right. And the force that's actually slowing the ball is directed this way. It's the force applied from the catcher's hand to the glove. So in this case, we're going to get, we've all learned that work, when the two of these are opposite directions, we're going to get a negative work value. So that's going to explain why our work is negative when we calculate for it. So let's go ahead and find what is our net work on the object. Starting off with the same equation we always start off with. And we notice that its initial speed is 30 meters per second, and it's going to be brought to rest. So it's V final 0. So we get 1/2, and our mass is 0.2. V final is 0, so that cancels this whole term out. And so you get a negative work, which explains this. So our picture explains that that's okay. So we get a negative 90 joules when you multiply that out. Now, how this is going to help us? Well, we ultimately want to know what is the force. What is the average force? Well, we know that the distance is 10 centimeters, which make sure we convert that to meters, which is 0.1 meters. We can use what we know that net work is equal to force times distance to solve for force. Rearrange the equation, you get force equals net work over distance. Plug in our values, negative 90 joules divided by a distance of 0.1. Actually, we do want to make sure that we say FD cosine theta. In this case, our theta is 180 degrees. Since they're not going in the same exact direction, the force is 180 degree difference than the displacement. So we want to write cos 180. Cos 180. And the cosine of 180 is just -1. So that leaves us with a positive force, which is what we want. So we end up coming up with a force of 900 newtons. And we're already taking care of the negative by showing that our net work is negative. So we don't want to have two negatives. So our overall force is 900 newtons.